Good morning, gentlemen. Today is Friday, May the 29th, and today we are going to talk about section 15.2. Motion is relative. Now, the first thing that I want you to remember as we discuss this is something that we talked about way back in the beginning of the year, that motion is a relative thing. Now, the example that we used in September, early October, was riding on a school bus. All right. If you're riding on a school bus that's driving up the Northway at 100 kilometers per hour relative to the ground, and you get up out of your seat and you walk toward the front of the bus at 2 kilometers per hour relative to the bus and your seat, then relative to the ground, you're moving at 102 kilometers per hour. If you then turn around and walk back the other way at 2 kilometers per hour, then relative to the bus, you're moving at 2 kilometers per hour, but relative to the ground, you're only moving at 98 kilometers per hour, even though the bus is still moving at 100 kilometers per hour. All right. And of course, this all depends on your frame of reference. Are you talking about your motion relative to the seat on the bus? Are you talking about your motion relative to the ground? Are you talking about the bus's motion relative to the ground? All right. So you really have to talk about and describe fully the frame of reference that you're discussing before you can get into any details about how motion moves. Now, why is this important? Well, recall from Wednesday's video that we are entering this discussion of the space-time continuum, and motion is either relative to space or it's relative to time. All right. And so that's why we're getting back into this. But I want you to think back to way back in the beginning of the semester, the year, about how we described motion as a relative kind of thing. All right. So keep that in mind. Now, the frame of reference also becomes important when when you are stationary, but the object that you are talking about or working with or interacting with somehow is in motion. All right. And I want to give you an example of this. All right. So let's say that you're having a catch with a baseball, for example, with one of your friends. All right. So you're standing on the ground and your friend is standing in the back of a pickup truck. All right. And you're throwing the baseball back and forth at 60 kilometers per hour. All right. So let's say that your friend throws you the baseball at 60 kilometers per hour from the back of a truck. Seems reasonable. Now, if the truck is stationary, the ball is going to hit your glove at 60 kilometers per hour, right? No, neither one of you is in motion relative to the other. And so the speed of the ball is a constant 60 kilometers per hour. However, if for whatever reason the truck is moving toward you, all right, first I suggest you jump out of the way. But secondly, if the truck is moving toward you at 40 kilometers per hour, and your friend throws the ball at 60 kilometers per hour, then the ball is going to reach you traveling at 100 kilometers per hour. That's a very fast ball. Okay. Now, on the other hand, if the truck is moving away from you at 40 kilometers per hour, and your friend throws the ball to you at 60 kilometers per hour, well, then it's only going to reach you. The ball is only going to reach you traveling at a speed of 20 kilometers per hour. All right. So again, motion is relative. You're stationary this whole time. All right. It's your friend who is in either stationary, moving toward you, or moving away from you. But regardless of his motion, he's throwing the ball at the same speed of 60 kilometers per hour. The speed at which the ball reaches you is going to be different depending upon his motion. If he's stationary, it reaches you at 60 kilometers per hour. If he's moving toward you, it reaches you moving faster than 60 kilometers per hour. And if he's moving away from you, the ball reaches you traveling at a speed less than 60 kilometers per hour. All right. So motion is relative, and it all depends upon your frame of reference. Okay. So that concludes our discussion of section 15.2. There is a set of a nice little set of diagrams on pages 214 and 215 in your textbook that kind of describes all of this, including a series of diagrams on the kid throwing a ball from the back of a truck there. All right. So please read through section 15.1 in your textbook, and I will see you on Monday. Have a great weekend.